I think I'm audible to you. Anyone who is watching live now or watching it after the live, thanks for attending our live session. Right, yeah, 400 people online solving this problem right now. Okay, please try again. Let me reload it. I'm solving this live. I'm just posting it in the discussion section of LeetCode problem number 42. That's what we will be solving today. So yes, here we are. Let's go and so we are given with this problem statement where non-native integers, we are given with n non-native integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So let me tell you, it would be better if we solve this for every index. Let me tell you, we are given with the height array, right? That's the first thing to notice. And let us take the height actually. Height is equal to 0, 1, 0, 2, 1, 0. 1 second. Yeah, 2, 1, 0, 1, 3, 2, 3, 2, 1, 2, 1, right? So this is it, right? This is the height. So I'll have 1, I'll have 2 here, and I'll have a 1 and then 0 and then 1 and then 3 and then a 2 and then a 1 and then 2 and then 1 and then 0. Right, now we have a problem is if it rains, 1 second, sorry for that. If it rains in this, just take these as building walls. Let us take these as walls. If it rains, you might confuse here, right? So if it rains here, it will store the rainwater here, right? And yeah, here and here. Will it store here? No, because it will flow like this, right? It will flow like this. So these are the places only where the water will be trapped or stored. And we need to return what is the number of units of water that is trapped after rain. I'm just taking as an example now. N is height dot length. Excuse me. N is length of height array. Right, that's what we are given with, only one array, and n can be till 2 into 1e4, and height can be till 1e5. Height of I can be till 1e5. Yeah. So if you see, I'm storing 1 unit here, 1 here, here another 1, here 2, right, here 2, right, here another 1, and then here another 1. So here I am storing 0, here 0, 0, 1, 2. Here I'm storing 1, if you see, and then a 2, and then a 1, 0, 0, 1, 0, 0. Yeah, that's it, right? That's what we are storing. But let me tell you how I could solve this. Let me just save the thought process for this. Imagine, just imagine, if I go from left to right, I need to understand where what amount of water can be stored at 0. Now, if you see, I'm starting at index 0 and it is already 0. Even if there is water here, it will flow outwards. So I'll not store it. Now, if you see, when I'm at index 1, you know, to store or trap the water, I need the left, something on the left, some wall on the left, and also on the right. Left wall and also right wall. Right, so one second, there might be an issue. Let me just reconnect. Yeah, so there should be a wall on the left and also on the right. Then only we can trap some water. Right? Now, imagine this. Just look at this wall, which is the maximum, right? Which is the maximum wall I can get. Now, will it store any water on above it? No. And you can look at this too, right? But let me tell you, can it store anything on the top? No, right? But before that, so here I have 3 as the unit of wall, and I cannot store anything on top of it, right? I cannot store anything on top of it. Why? Because I don't have something on the right which is of the same size, which is a wall of same size or greater than that, right? On the right or on the left, I didn't have any wall which is of size 3 or more. If I have a wall of size, even 3 is not sufficient. We should have some 4, right? Let me tell you, even if I have a 4 here, I cannot store a unit of water. Why? Because it will spill out, right? I need something on the right, something like here, which is of size 4 again, so that I can store 1 unit of water here, right? So what I'm looking at, every index I'm looking at max on right and max on left. Let us just take one index and let us understand how much amount of water will be stored, right? Let me explain you how much amount of water will be stored without any further delay, right? Yeah, yeah, let me tell you one thing. At this point, at this point, which is some index. Now, here you can just see what is the maximum on the left. For left, the maximum is 2 here. So 2 is the maximum wall I have on the left. So it is 2. Now on the right, from this index, I have 3 as the maximum wall. So on the right, I have 3. Now if you see, even I have 3 and also 2, I cannot store 3 units of water. Why? Because the maximum I can have is 3, but the minimum is 2. So the water which will be on this will be slipped out. It cannot be stored at this index. So if you see, we are not gonna have the answer 2, right? So here the water trapped stored at index I, which is nothing but answer of I. I'm just storing like this. Answer of I will be the minimum of max of left, max of left, max of right, max. Let me tell you, minimum of. Let me tell you what I'll do is store store maximum left at every index, left and right, left and right at every index. Maximum height to the left, maximum height to the right. Store maximum height to the left, maximum height to the left and right at every index. For this index, sorry, for this index, I have maximum on the left is 2. Just height, just height need to be stored. Maximum on the right is 3. Just you need to store, right? So I'll store this in left of I, right of I, just those arrays, right? So minimum of left of I comma right of I. But there is a problem here. Let us look at this index, and you can say that the minimum of left of I and right of I. Left of I is still 2, right? That's the maximum I can get. Sorry, that's the maximum I can get here. Maximum 2. The wall is of 2 height. Now to the right I have 3. That's the maximum, right? But if you see, if I just take minimum of left of I, right of I, I'll get 2 as the answer. But if you see, storing, I'm just storing only 1 unit of water here, right? I'm just storing 1 unit of water, while my answer is, minimum of left of I and right of I is 2, right? Here 2, but I'm not getting 2 as the answer. So what I'll do is the wall should be removed. The wall should be removed. So I'll just remove height of I. I'll just subtract height of I, right? So just simple. First, first do one thing. The algorithm is do one thing. First, left of I and right of I, right? So initialize left, right of the same size of n. Left and right should should store maximum to the left at index I. Same with right, to left or right. Maximum to left or right at index I. Yeah, so that's the first thing. Now I have left of I and right of I. Now I'll just iterate for I is equal to 0, I is less than n, I plus plus. So what I'll do is answer will be incremented with minimum of left of I comma right of I minus height of I, right? Yeah, that's it, right? So I can write the code for this, but anyone watching this live, right? I know there are some few people who are watching this live. I want you to first try code by yourself, right? You can just send your code in live chat. We'll just review it, right? Yeah, we'll just wait for another 5 minutes. It's just 15 minutes that I have explained this problem. I can code this, but I'm waiting for you to reply in the live chat, right? So it's 9:47. We'll just wait for 9:52. Just 5 minutes. And we'll return the answer at the end. And don't forget these small things like initializing n and initializing answer, all these things. Yeah, I think, yeah, we'll just wait for another 4 minutes. Let's not hurry up with the code. can start our code right now without wasting any of our time. So what I'm thinking is initializing both left and right array. So first thing, int, I'll just write the code. Int n is equal to height dot size. Then what we'll do, vector of int, yeah, left of size n, and let's initialize it as 0, and right of n and also 0. Now left of 0 will be nums of 0. Why? Because we have something like this. Now I'm saying that to this, or to this, the maximum will be 2, right? Because it is having 2. But for this it is just itself, right? So that's why I'm taking left of 0 is equal to nums of 0. And that's the same thing which I'll do with right of n minus 1 will be equal to nums of n minus 1, right? Now what I'll do further is let me take left, get the left and also the right. So for I is equal to 1, I is less than n, I plus plus, left of I is equal to max of height of I, comma, left of I minus 1. That's it. Now I'll do the same thing with for I is equal to n minus 2, I is greater than or equal to 0, I minus minus, and right of I is equal to max of height of I, definitely height of I, I'm just checking the current height, and right of I plus 1. Alright, now I'll just go through with int answer is equal to 0. For I is equal to 0, I is less than n, I plus plus, answer plus is equal to minimum of left of I, comma, right of I minus the current height of I. That's it, and return the answer at the end. There are like, let me tell you how many have solved this. Just attempted 5 million, that means 56 lakh people have attempted this, and 38 lakh coders have got this accepted, and we are one of them, and you'll also be one of them. And let's just take int n is equal to height dot okay, height dot size. Now vector of int left of n comma 0, right of n comma 0. Now left of okay, sorry, left of 0 is equal to nums of 0, right of n minus 1 is equal to nums of n minus 1. Okay, for int I is equal to 1, I is less than n, I plus plus, left of I is equal to max of height of I, comma, left of I minus 1. Right, now for int I is equal to n minus 2, I is greater than or equal to I minus minus, and right of I is equal to max of height of I, comma, right of I, then int answer is equal to 0. I'm just copying that which I just wrote. Right answer plus is equal to minimum of left of I, comma, right of I, then minus height of I, oh sorry, height of I, then return the answer at the end. I think sorry, height height Okay, let me run that. Okay, we got the output as 0. We need to change something. Let me tell you. I plus 1. Yeah, just a simple error can make it just like that, and we're just missing out every day that we aren't calculating the time and space complexity, right? So yeah, for this, the time complexity will be, I'm just iterating the array for how many times? 3 times, right? So time complexity will be big of 3n, and the space complexity I'm just using left and right, which is of big of 2n. Yeah. So I think that's it for today. And if you have any doubts, please let me know. And I'll be there till 9:30. Sorry, 10:30. We just started this live stream at 9:30, so we'll be till 10:30. Right. So till then, if you have any doubts, I'll just keep it like this. Do subscribe. Your doubts. And yeah, let us just